Hey guys, welcome to Chem. I want to talk to you about section 12.3 in your book, which is about solubility, and give you a couple of quick notes here before you get too far and get confused. So, solubility, okay, that's the maximum amount of solute or the powdery Kool-Aid, the lesser amount, that can dissolve in a specific amount of solvent, like the water per se, at a given temperature. Okay, so you got to keep a couple things constant here. You can't change too many things, otherwise solubility gets goofed up. So I'm going to write this for you. So it's the maximum amount of solute. Again, that's like Kool-Aid, so I'll write the lesser amount. And if you want to write that little clue for yourself, like the powder, powder Kool-Aid, the maximum amount of solute that can dissolve, in a given amount of solvent, and that's the larger amount. It's like the water for the Kool-Aid, at a given temperature. Okay. Some things, factors rather, can affect solubility, and one major thing is temperature. Okay. But it's different for solids versus gases. So, when you're talking about solids, so for example, sugar water like Kool-Aid, or lots of you I know drink coffee. If you put sugar in your coffee, okay, the temperature of the solvent is going to determine the solubility of that solution. Okay, so for solids like sugar, as temperature increases, I'm just going to write in red really quick, solids only here. Okay, so for solids only, as temperature increases, so as temperature goes up, solubility, it also increases. So it's a direct relationship. Okay. Okay. And so, for example, like I was talking about with the hot coffee or hot tea, hot coffee can dissolve more sugar than a cold coffee or an iced coffee. Okay. Now for gases, okay, it's a different relationship. Oops, I want to write in red. Okay, it's different. So as temperature increases with a gas, the solubility of that gas decreases. And I'll explain what I mean by that. So as temperature goes up, solubility goes down. Okay, that is an indirect or inverse relationship. So a way to explain that would be like a can of pop. So if you open up a can of pop and let's just say you take a couple sips and you don't finish it, if you leave it outside on a hot day and you come back to it and drink it, it goes flat pretty quickly. However, if you take, a couple sips out of a can of pop and stick it in the refrigerator to keep it cold, when you come back to it, it won't be as flat as it would have been if you left it out even at room temperature or on a hot day. Um, and if you think back to what you know about gases, right, as you heat a gas up, the little gas particles move around a lot more quickly. So, the solubility of a gas, as you increase the temperature, it's going to escape that liquid much more quickly. Okay, so I'll write the example here. Pop will go flat. Faster in warmer temperatures. Okay. So another portion of this section talks about saturated and unsaturated solutions. Um, there's a fine line between a saturated and an unsaturated solution. In another video we're going to look at is going to be looking at solution curves. So I'll get deeper into that in the next video, but I just wanted to kind of plant the seed here. So an unsaturated solution. Okay. The solvent does not contain the maximum amount of solute. Okay, the solvent, which is the larger amount, like the water for the Kool-Aid, it does not contain the maximum amount of solute. That's the lesser amount. The Kool-Aid, the powdered Kool-Aid. Okay. So what that means is let's pretend that you have a glass of water and you put some Kool-Aid into it. As you put the Kool-Aid in and then you stir it, it's going to dissolve. You add a little bit more in, it's going to dissolve. You add a little bit more in, it's going to dissolve. So as long as it continues to dissolve and you've got no particles, solid particles on the bottom, it's an unsaturated solution. Okay, so we're going to say no solid on the bottom, and the solute easily dissolves. Okay, but at a certain point, you are going to get a saturated solution. So at a certain point, you're going to dump in another teaspoon or however much of that powdered Kool-Aid, that sugar, and you're going to start to see solid on the bottom. When you see that solid, those little crystals on the bottom, you've got a saturated solution. Okay. What happens is the solution contains all of that solute, that powder, that it can dissolve. It literally cannot dissolve anymore. It cannot take any more. Okay. So a solution. So like the Kool-Aid, that liquid Kool-Aid solution, that mixture contains all the solute that it can dissolve. And there will be solid on the bottom. Okay. When you see that solid on the bottom, that's called recrystallization. Oops. Okay. And that's as far as I'm going to go in this video. I'll make another video to talk about the solubility curves. Email me if you have questions.